everyone, I'm Lizelle and welcome back to Kazimula Applied Sciences. This lesson, we continue with momentum and we will look at two concepts, namely change of momentum and the vector nature of momentum. So you will recall that all moving objects always have momentum that is greater than zero because momentum is the product of an object's mass and velocity. And if the velocity is greater than zero, so will be its momentum. But if an object is stationary, that would necessarily mean that it has zero momentum. Why? Because its velocity is zero, its momentum will therefore also be zero because momentum is the product of mass and velocity of an object. But what if the velocity of an object is changing? If the velocity is changing, we denote it with delta V. That would immediately mean that we also have a change in momentum. And how would we calculate that change in momentum? Well, we have this formula that says that the change in momentum is the final momentum, take away the initial momentum. Remember, in physics, the change in anything is denoted by delta and whatever that physical quantity symbol would be. And the change in any physical quantity in physics is always the final value of that physical quantity, take away the initial value of that physical quantity. So the final momentum would simply be mass times final velocity. And I subtract the initial momentum as the product of mass and initial velocity. That obviously now boils down to m, open bracket, v final, take away v initial, because in these two terms we have mass as our common factor. We take that out, and what is left in each of those terms would be v final, take away v initial. Please therefore take note that we can have this formula for momentum, delta, let us say that it would be delta P is equal to final take away initial momenta. It is also equal to mass times change in velocity, and that is also equal to mass multiplied with final take away initial velocity. Let's look at an example. So we can draw vector diagrams of the velocity of any object because velocity is a vector. And that simply means that it would be shown as an arrow pointing in a certain direction with a certain length, because a vector has both magnitude given by the length of that arrow and direction given by the arrowhead of that arrow or the direction of that arrow. So we've got two cases where a tennis ball approaches a wall and then rebounds off of it. In the first case, it approaches the wall with a velocity of 10 meters per second and rebounds with a velocity of 5 meters per second. And in the second case B, you have an initial velocity approaching the wall with a velocity of 30 meters per second and rebounding off the wall with a velocity of 28 meters per second. In each of these cases, you have to comment on three things. In which case will you have the greatest velocity change, the greatest acceleration, and the greatest change in momentum? Let's get started. So you have to work out the change in velocity in each case. We know that in case A, the change in velocity will be the final velocity, take away the initial velocity. The final velocity, before we continue with that, because we are dealing with vectors, you now have to choose a direction to be positive. If we choose away from the wall, for example, to be our positive direction, clearly towards the wall would be denoted by a negative sign, because that goes in the opposite direction to our positive direction. So our final velocity would have a vector quantity value of positive 5 meters per second. I subtract my initial velocity, and that initial velocity vector direction is in the negative direction. So I'm going to show that as negative 10 because it moves in a negative direction at 10 meters per second. So that gives us 5 plus 10, because negative times negative is positive, and that is 15 meters per second. We can also work out the change in velocity for case A, case B, which will be the final velocity, take away the initial velocity once again. The final velocity is positive 28 meters per second. I subtract the initial velocity, which goes in the negative direction, as negative 30 meters per second, and that gives me 28 plus 30, which is a positive value of 58 meters per second. Which of these two cases will have the greatest velocity change? Clearly, that would be case B, because 58 is greater than 15 meters per second. Where do you have the greatest acceleration? Now, remember, acceleration is the rate of change in velocity. So it's delta V over delta T. If in both of these cases, the ball makes contact with the wall with the same over the same period of time, but only the velocity changes, the greater velocity change would yield the greatest acceleration, which will obviously be that for case B. The greatest change in momentum, as we know, change in momentum is mass multiplied by the change in velocity. The mass of the ball do not change in these two cases, even before and after collision. But the velocity change, so the greater velocity change, would yield the greater change in momentum. Again, that would be case B, because in case B, you had the greatest change in velocity. The vector nature, therefore, of momentum is extremely important as a concept. That means in these problems, we always have to choose a direction to be positive. First of all, a direction as positive. Very important. So in this example, we've got a ball of 2 kilograms that strikes a plate at a speed of 20 meters per second. And it rebounds at a speed of 15 meters per second. Calculate the change in momentum. So if we choose up to be positive, then clearly if the ball drops, that moves in the downward direction, that would be a negative direction. And so its velocity with which it hits the plate would be negative 20 meters per second. If it rebounds off of the plate, that velocity would be positive 15 meters per second given to us. We now have to work out the change in momentum as the product of mass and velocity. Final, take away the product of mass and velocity initial. The mass is given to me as 2 kilograms. The final velocity is 15 meters per second, which will be positive. I subtract the mass, which is still 2 kilograms, multiplied with the initial velocity, but now the vector nature has to reflect as a negative sign in front of the 20. And that gives us 30 plus 40, which is positive 70 kilograms meters per second as the unit. We can now also look at vector diagrams that would represent momentum. We know that both velocity and momentum are vector quantities, and so we can represent both velocity and momentum with vector diagrams, which would simply show arrows in a specific direction, which will have a certain length to show the magnitude of that vector. So let's look at this example. You've got a cricket ball with a mass of 70 grams traveling horizontally at 35 meters per second. The ball is struck by a cricketer called Amla, and it moves horizontally away from the bat in the opposite direction at 50 meters per second. What is given to us? Let us first analyze this. The mass is given, but in grams. So you have to convert this to kilograms by dividing grams by 1,000. that will yield 0.07 kilograms, because the SI standard international unit for mass in physics is always kilograms. Only in chemistry is the SI unit grams. So you have to convert to kilograms. This is in the correct unit, and this is in the correct unit. This is given as my initial velocity, and this is my final velocity. You have to now work out the change in momentum of the ball, and then you have to draw a vector diagram of the initial, final, and change in momentum. I would like you to pause the video, quickly do this by yourself, and then play the video again to see if you have done it correctly. So this is what you should have done for the first answer. We always have to choose a direction to be positive first. And we say that towards the bat will be our positive direction, right? So the mass we have been given as 0.07 kilograms. The initial velocity is positive 35 meters per second, because that moves initially towards the bat, and then it rebounds, it gets hit off of the bat, it moves off of the bat in the opposite direction to the positive direction, which means we're going to show that with a negative sign to reflect the vector nature of momentum and of velocity. So to work out the change in momentum, I have this formula: mv final take away mv initial. You substitute your values in with the correct signs as from above, and you get negative 5.95. You will always have to change that negative answer to a positive answer with the correctly reflected direction. So that would mean it moves at 5.95 kilogram meters per second away from the bat, because the answer is negative, and towards the bat was a positive answer. To then draw the vector diagrams of this, we have the initial momentum as m times v initial, and that value is given as positive 2.45 kilograms meters per second. It moves towards the bat, and the length of that arrow and the direction of the arrowhead will show you also the direction of that momentum. It points towards the bat, and it is only 2.45 kilogram meter per second in magnitude. The final momentum is negative 3.5 kilogram meters per second. It therefore has to reverse direction opposite to the initial positive direction, and it will have to be drawn longer than the initial momentum, because it's a greater value, but in the negative direction. The momentum is clearly bigger than both the initial or final momenta, because in this case, we are subtracting a negative value. So positive 2.45 take away negative 3.5 gives us that value of 5.95 kilograms. We have worked it out above, and we got negative 5.95 kilogram meter per second. That therefore points in the negative direction away from the bat, and it should be drawn longer than the initial and final vectors of momentum, respectively. We will end our lesson here with these two concepts. Thanks for watching, and I hope that you have found this helpful. Please join us again. Thank you. Bye-bye.